about slope-intercept form, y equals mx plus b, which is slope-intercept form. And again, this is the most common form that in the past you've learned to write these problems in. It's the most common form that you usually see them written in already ahead of time. But there's another type that's actually a little more helpful for a lot of problems. Oops, and I made a mistake there real quick. Where we just say y minus y1 equals m times x minus x1. This is known as the point slope formula, or point slope form. Now, just like in our previous problem, or previous form up on top, m was the slope, b was the y-intercept. Here, the m is still going to be the slope, so that's not going to change. The other parts of this equation where we will substitute in, the y1 and the x1 come from some point that we're given. The y itself and the x itself, those are going to be our variables, just like y and x were in slope-intercept form. Now, point slope form, most of the time when we decide to use this, two things. The obvious one, a point and a slope, might mean they give us some point and they give us some slope. We substitute in. Usually we'll simplify it down to slope-intercept form, but that's one option. The second option would be one where maybe they give us 2 points, and then we use those 2 points to solve for our slope. Because then when we substitute back in, we'll have a slope to plug in here, and then we have our choice. Either we can let this one be x1 and y1, or we can let our second variable be x1 and y1. And even though when you first plug it in, those two options are going to look completely different because we're using 2 different points, once you simplify, reduce everything, and turn it back into slope-intercept form for your final solution, they're going to get you the same answer no matter which point A or point B, you choose to use. So let's take a look at an example here. We'll start out on this one with that first idea where they're going to give us a point. And we'll do the point 1, negative 2. And they'll give us a slope. And in this case, we're going to work with a slope of 3. So let's set up our values. So our form, we have a point, we have a slope, leads directly to point slope form. So y minus y1 equals m times x minus x1. And then again, we're going to substitute in here, here, and here. The y and the x stay the same. So on this one, the y value, negative 2, so we're going to have y minus negative 2 equals our slope of 3, and then x minus our x1, which is 1. So we can simplify. A negative times a negative is a positive, which if I go to simplify my whole equation here, I'm going to end up with this. Y plus 2 equals, I can do distributive property, 3 times x, 3 times negative 1, and then I just subtract 2 from both sides. That reduces, I get y equals 3x minus 4. So there's the equation that would include the point 1, negative 2, and have a slope of 3. So one like this where they give us x1, y1, and they give us a slope, fairly simple. Plug and solve. All right, let's look at one where they give us 2 points. Okay. So this one, we're going to look at our 2 points. Let's go with this. Point A, we'll put at 3, 5. Point B, we'll put at negative 2, 4. So again, if we're going to substitute into our point slope form, y minus y1 equals m times x minus x1. Right now, I don't have my value for m. So we have to do a little side work here and find our slope. So let's again do change in y over change in x. So the y's goes from 5 to 4, so that's down 1. And the x's from 3 to negative 2, that's down 5. Negative divided by negative simplifies into positive 1/5. So now I have my slope, 1/5. I know I'm going to keep my x. I know I'm going to keep my y. Now it's my choice if I want this to be x1, y1, or if I want this to be x1, y1. And it doesn't matter. I'm just going to pick this second one. So I'm going to let this be x1 and this be y1. So I'm going to go minus 4. And on this side, I'm going to go minus a negative 2. So let's simplify this. So I get y minus 4 equals, and I can do distributive here, 1/5 times x. And 1/5, here we've got a negative times a negative, which is positive. So 1/5 times positive 2 is positive 2/5. And then simplify and finish by adding 4 to both sides. So I'm going to get y equals 1/5 x. And here 4 would be the same as 20/5 if I want to get a common denominator. So I'm going to get plus 22/5. And there's our equation. So this would be the only linear equation that's going to go through those 2 points at the same time. Let's extend our talk here now, dealing with slopes. Let's talk about 2 specific slopes. And we already talked about them a little bit in one of the previous slides on here, where if we had 2 parallel slopes, what that's going to tell me is both of them have the same slope. And I probably should change this so it's not parallel slopes, but parallel lines. So parallel lines always have the same slope. Our other option for 2 special types, perpendicular lines. And 2 lines that are perpendicular, their slopes are opposite reciprocals of each other. One other way to test that, if you do a multiplication of your 2 slopes of the 2 lines that are perpendicular, you should always get -1 when you multiply those 2 together. Again, opposite reciprocals. So let's set up an option here and see how we can apply these. Alright, first one we're going to do, we're going to start out with an equation. And our beginning equation is just going to be 2x minus 3y equals 5. So our first thing that we want to do is, with this one, and let's also define a point that we're going to go through. So we're going to go through point 2, -1. Alright, so we have 2 options with this. First option is going to be trying to find a solution parallel. So let's do parallel. If it's parallel, remember, we need to have a line go through this point, but be parallel or have the same slope as this equation. So let's do a little side work here again on this one. Let's take our 2x minus 3y equals 5, and let's break this down so we can actually find our slope. So we're going to subtract 2x on both sides, cancel that, bring down the -3y. We're just going to divide both sides by -3. So when we simplify this, we get y equals positive 2/3 x minus 5/3. Now, this, remember, is an equivalent equation to the one we started with, just in slope-intercept form, and the reason we need this slope to make some decisions. So let's go back to finding our parallel line. We're still going to have a slope, which we just found, and a point. So let's go right to point-slope formula. So y minus y1 equals m times x minus x1. It's probably not a bad idea to write this formula every time you do a problem until it sticks in your head. And let's substitute in. The point that we're going to use, x1 and y1, comes from the given point. The slope, since the line is parallel, is going to be this same slope here. So let's plug in. So y minus, and y1 is negative 1. Slope, which we just found, 2/3, times x minus, and x1 was 2. Simple as that. So if we simplify here, negative times negative becomes positive, and over here we can do distributive, so we're just going to get y plus 1 equals 2/3 times x is 2/3 x, 2/3 times 2 is negative 4/3, and then if we subtract 1, if we need a common denominator, we're actually going to subtract 3/3 and subtract 3/3. So that cancels, and we're left with y equals 2/3 x minus 7/3. So what we actually just found was this line will be parallel to the original line, but our new line will also run through point 2, negative 1. Alright, let's take a look at the option where, same idea, still has a line that we're given, still has a point that we're going to go through with our new line, but this time let's look at the situation where the two lines that we finish with are perpendicular to each other. So in other words, my new line has to go through 2, negative 1, but it has to be perpendicular to my original line. So again, the points that the things that we know a point, we know a slope. Point-slope form. So again, let's fill in what we know. We're going to do y minus our y1, which is negative 1. The slope, remember this time we have to do opposite reciprocal. So reciprocal of 2/3 is 3/2, and since our original is positive, we're going to make our new slope negative. So negative 3/2. X minus our x1, which is 2. So again, minus a minus is plus, so we get y plus 1, and over here distribute. Negative 3/2 times x is negative 3/2 x. A negative times a negative is a positive, and 3/2 times 2 is just 3. Subtract 1 from each side, simplify, and we get y equals negative 3/2 x plus 2. So if we were to graph all three of these, this would be our original line. This line would be the line that goes through point 2, negative 1, and it would be parallel to our original line. And this line would be the line that goes through point 2, negative 1, but is perpendicular to our original line. And that pretty much takes care of everything that we're dealing with in section 1.3. Again, all of this can be used as application problems or within application problems to go through and simplify. So, good luck with section 1.3.